Now we're going to move into the part of trigonometry where we are not necessarily guaranteed to have a right triangle. So our first couple lessons dealt entirely with right triangle trigonometry. Now we're not going to have a right angle, so this is going to require us to learn a couple more laws or properties here to help us solve any given triangle. So if we have no right angle, at a minimum what we need is at least one side given to us in order for us to use one of our two laws of trigonometry to actually solve the triangle. And if you recall, if you had three angles that were given in a triangle, those side lengths could technically be anything. You could have multiple triangles that have the same set of angles. So we can't define the triangle by its set of angles, so we need at a minimum one given side. Now, as a result of that, this is going to break down to four possibilities. And if you look here at these four possibilities, two of them are going to be solved by using the law of sines. And two possible scenarios are going to be using the law of cosines. Now, you may have used these in geometry. And what we're going to do in this course is we're going to actually take the law of sines just a little bit deeper, and we're going to talk about some of the nuances of some of these particular problems. So in geometry, you may have been introduced to it and been given some very straightforward problems to work where nothing really tricky happened. Now we want to introduce you to the ideas of some of the hurdles that you could run into along the way and how to react to them. So the first thing we're going to do is the law of sines. In our next lesson, we'll get into the law of cosines. Now, generally speaking, the law of sines is a result of finding the height of a given triangle from two particular points of view. So if we have a non-right triangle, like you see here, we have triangle ABC, we can draw an altitude that represents the height. Interestingly enough, we can actually represent that height measurement as a sine of angle A. We can also represent that height measurement as a sine of angle B. And in doing so, you create two equivalent trig statements there whenever you make H equal to itself. So you can see that we end up with a proportion, the sine of A of angle A over side length A equals the sine of angle B over side length B. Now, let me make a point here that you should have learned in geometry. If you notice, angle A and side A are opposite of each other. So angle A is always going to be a capital letter, and side A is going to be a lowercase letter, and you should have learned that in geometry. So this should happen all the way around the triangle. Notice the same thing happens with angle B and side B, and angle C and side C. So generally, if we give you a problem and we don't give you the actual visual, we just say triangle ABC, you would definitely want to set up your angles and your side lengths in the appropriate manner so that you do not mess up your given law of sines. Now, if we can set up a proportion between two particular angles and two particular sides, we can set up that same proportion and we can draw a different altitude. Instead of from angle C to base C, we can draw that altitude a different way and set up a different proportion with the sine of angle C and the side of C. So in doing this, we can then create the law of sines, which basically gives us a three-part proportion with the sine of A, the sine of B, and the sine of C. Now, whenever we get our problem, we're only going to be given a certain amount of information. Well, what should happen in theory, if the law of sines is going to work, is that one of the ratios in this three-part proportion should be completely filled out, and that particular ratio is the one we're going to use to actually solve the given problem. Now, you can see in this little content box that you can write the proportion or you can write the ratios in either way, with the sign of the angle on top or the bottom of the fraction. So either way that you choose to write it is is correct. So, all right, in the next video, we'll take a look at an example and work a sample problem.